So good afternoon, everybody. We're just going to wait a couple of minutes until we get to the top of the hour for us to start. I see people gradually joining us. So welcome. We'll be with you in a couple of minutes' time. So good afternoon, everybody. We're just waiting for more people to attend. We're a couple of minutes or so before the hour, and we'll start about 30 seconds after 2 o'clock, everybody. Okay, we're going to kick off now, everybody. So good afternoon. My name's Ian Machin, and I'm at the Advanced Services Group. It's my pleasure today to introduce you to Engineering Design for Services webinar, and in particular our speaker, Andrew Harrison, who you'll hear from shortly, and we'll take you through the next hour or so of this webinar. I'll just run you through the agenda for the session. We're going to just do a short introduction for those of you that don't know anything about the Advanced Services Group, about ourselves and what we do, and I'll introduce you to Andrew Harrison. We'll then spend the bulk of the time having Andrew answer the question, what is engineering design for service? We'll then explore the 5 principles that you'll come to know and love during the session today. And once we've been through that, we'll open up the floor for audience Q&A. If you've got any questions about the topic, and for Andy, if you could please use the Q&A function within Zoom, if you would please, and that allows us to collect them. And then I will use those during the Q&A session to put the questions to Andrew. The session is being recorded today so that you're aware. And then we'll then also go into a piece at the end. We'll just tell you about how if you think this is of interest to you and it can help your business, how you can engage with ASG with our Engineering Design for Service offer, and we'll then close out at the end of the hour as well. So that's the plan that we'll go through for today. So the Advanced Services Group, we are a centre of excellence in servitization research coming out of Aston Business School. We provide education training, we do lots of research, and we are all about helping global manufacturers to be able to help them to change their business model, to be able to innovate through service-led strategies. So my name's Ian Machin, I'm the Commercial Director, my contact details are there. You can see on the left-hand side in the box, and if this is of interest to you and you'd like to engage further, there are 3 key ways, and we'll remind you at the end of the session as well. We have a brand new mini guide, which is on the topic of engineering design for services, and that'll be on our website today, and that gives you access to the online game. You'll see some screenshots today, and Andy will explain to you. We also run an in-house education workshop program where we can help you, your designer technical teams, how to use the 5 principles to improve your design for service. And we also provide a process whereby we can help through a range of workshops, introduce our combined IP from our advanced services work, the Engineering Design for Service IP to help you better understand the outcome that you're trying to provide to your customers, and then learn how to apply for your own products, Engineering Design for Service, to make sure your product design is right. So you'll see that at the end, but please get in contact with us if we can help in any other way. Before I move on to the rest of the webinar, I just need to remind everybody we have a major event taking place in October, 4th to the 6th of October. It's a virtual event called Servitization Live. It's everything about as a service. It comes on the back of the World Servitization Convention that we ran last year in September. Registration is open, it's free. It'll give you a great insight into how manufacturing businesses are applying servitization across a wide range of different fields. So please put the date in the diary, and please, you're welcome to come along and experience servitization from the best. So I'm delighted today to introduce you to Andrew Harrison. Andy, as you can see from his biography on the screen, has been with Rolls-Royce for over 30 years. He spent time in product development and in service support, and then has spent over 17 years working in the field of life cycle support for engineering and design. Just to take you back a slide. And that's the basis of the work that you're going to see presented today. Andy has been preeminent at a national level in spreading the capability for design for service through both as an honorary professor at Aston University, at Cranford University, and working as a founding member of the Thruloff Engineering Services Council, and was instrumental in the publication of a British Institute standard in this field as well. Andy, it's great to see you today. I'm just going to use the opportunity to introduce one of the models that we have within ASG portfolio, and then we're going to I'll hand over to you, Andy, and you can then take us through the Engineering Design for Service piece, if that's okay.
Yeah, fine, thank you.
So what I've got on the screen here is the services staircase, and the reason we put this up is one of the models that we use to explain to manufacturers how you can compete in different ways. And the services staircase shows that as you move up the staircase from bottom to top, you're looking to add increasing value to the customer that would buy your product or your service. And as you move from left to right along the x-axis, essentially you're looking to create a competitive advantage by adding in extra value services and the absorption of risk away from the customer. And as you move up that staircase, we move from traditional manufacturing of product spares, the orange area, to the intermediate areas where you're offering services around break fix, training, assured maintenance, moving into performance advisory, advising customers how they can get most out of their assets. And the top area is around guaranteed outcomes at the product level, process level, and platform level. So those are four key areas: the basic, intermediate, performance advisory, and then the advanced, that shows how you can progress your service offers. So that's the background, I guess, of how we can offer things to the customer. Andy, if I hand over to you, I guess the question of how that fits in with Engineering Design Service and how the service is essentially being put together and being sold initially is I guess, the starting point, isn't it?
It is, yeah. So, one of the first things you've got to consider is, do we need to design a product to support a service, or are they not independent things that get offered at two different points in the life cycle? And probably the easiest way to illustrate it would be with an example. So if you just consider the cheap and cheerful pen, so something that provides you with the ability to write. If you were at the very bottom of that staircase, all you're really supplying is a pen. So if you ask the product designer, what does a pen need to look like? In all likelihood, you'll get an answer back saying it's something that provides ink onto a bit of paper. Generally, we're told it needs to be very cheap. The salesman tells us the best way to sell it is to make sure it's the cheapest thing being advertised on Amazon. So you end up with a Bic or some equivalent ballpoint pen. And that's really the basis of the design principle. You may then go into the kind of more intermediate levels, and maybe the salesmen have decided that actually, rather than selling individual pens to people, what we want to do is provide a service where we guarantee that a working pen is always available. So maybe you're supporting an office environment and just keeping the stationery cupboard suitably well stocked. And that becomes a slightly different proposition, because now you want to guarantee that there's always a working pen. And you can do that a number of ways. You can stick with your cheap and cheerful biro and just make sure there are always lots of them in the cupboard, so that when you pick one out and it doesn't work, you throw it in the bin and you go and get the next one. Or you could aim for something which is slightly more reliable, maybe has a longer shelf life where the ink still continues to flow. So you're going to have to think more carefully about what the design requirement is for that product in order to meet that particular need. And then if you went to the very top of the ladder, maybe what you're guaranteeing is pages of writing and the ability to produce those in a fixed length of time. And then your service offering might get different again, not least of which because you may no longer be selling the pen as an artifact. What you're selling is pages of writing. And that becomes tricky, because how are you going to know how many pages of writing were done? So maybe your pen now needs to incorporate some kind of methodology for determining what the level of ink usage is, so that you can get a correction back to the number of pages of writing that are produced. So you can see on that, relatively simple example, as you progress through the staircase and are offering different types of service, it will inevitably have some kind of effect on the requirements for the product that best meet that. And what you tend to find very much in industry is most people are progressing from a product design, manufacture and sales world into offering some kind of service offering around it. And inevitably, almost the first thing that happens is a service gets bolted on top of an existing product. And you can find that these mismatches between what the product's capable of and the service that's being sold can be the difference between success or failure in that entering into that service world. So the whole point of design for service is that you try and get that alignment. You make sure that the product that you're offering has the characteristics that allow it to support the service offering in an effective and profitable manner for most organizations. If you could move me on to the next slide, or if I can do it. You might have to move me on, Ian, if you're in control. Thank you. So the basic, Ian talked a little bit about the mini guide and the workshop pack that we put around that. So both basically work their way through 5 principles. So I guess the key thing to say is there's nothing particularly clever or different about designing for service than there is for designing for any other requirement. But what it does require you to do is to think differently and outside of the normal box that as product for sales designers we might normally get stuck in. So the 5 principles are not particularly radical, but if you go through them in the right sequence, they do force you to think about the right activities and focus your attention in the right place. So the short description of them, principle 1 is know what service is being sold. So you really need to understand if the sales team are out selling boxes of pens, or they're selling guarantees that a working pen is always going to be available, or they're selling pages of writing output, because that's fundamental to understanding what the requirements of the product are going to be. Principle 2 then takes you into, so what does the product need to be able to do in order to work in that kind of sales and service environment? What are its key features? How long do they have to work for? How reliable does it have to be? So you're trying to get that true understanding of what needs to be in the requirements document wrapped around that component in order to, or that product in order to make it work effectively. Principle 3 then says, take a step back and have a look at how good your prior products have been, or the current one, when you compare them to the requirements. And quite often you'll find that you're already meeting some of the requirements, or your pedigree says you're going to meet some of them, and there'll be some areas where there are gaps, where you're not lining up, or you expect there to be a shortfall, or there may be even some areas in which you expect to exceed the requirements quite easily. And getting that holistic view of where to pay attention, where might the opportunities lie in order to drive things forward is fundamental. So not trying to change everything, just focusing your attention on those areas where the greatest opportunity lies. Principle 4 is where the engineering really kicks in heavily, because it says, don't fix the outcome, go and fix the cause. So when you've decided that there's an opportunity area, so maybe your product is doesn't last and work for long enough, maybe it's not reliable enough, understanding why is absolutely crucial. It means you can go back and you can make a change to the thing that's going to have the most influence. And quite often that's in a very different place to where you're seeing the outcomes that you're measuring. So, you know, you may have an example where you're seeing very high costs of repair of a product during its life, and you may immediately go and focus your attention on cost reducing the repair process. But there are many places upstream of the repair activity that can have an equal, if not greater, impact. So why was it ever in need of repair in the first place? If you can reduce the rate at which it wears out, then you can remove the need for any kind of repair activity to place. So it doesn't matter how expensive the repair is, because you're not going to do it. And then principle 5 is getting into the detail of what are you physically going to change in the product. And at that point in the process, we talk about the difference between avoiding things happening and making them more palatable when they've happened, and making sure you get the right balance, because there are generally many different ways in which you can improve a product and its service characteristics. Choosing the right place to go and apply pressure can make your life very easy or very difficult to get the right kind of outcome. So we talk through those sort of the mechanics of how do you get to that best outcome for least effort as you go through. If you move me to the next one, Ian. Hopefully, he says. Thank you. Yeah, it's back one. So when we do the mini guide is essentially a written document. So it's available for you to read through. It talks through the principles. It provides worked examples of how they might look in particular scenarios. But it's accompanied with the opportunity to have a go at an online game. And the game has been derived from experience we've picked up over the last 20 years trying to do this kind of training in particular in Rolls-Royce and other organizations. And it uses the example of a washing machine, and in particular a washing machine that's being designed to support the laundrette or the industrial cleaning industry. And it allows you to make decisions about how to design that machine. So there are essentially 3 components that make up a machine: the casing, the door, and the motor and drum assembly. You have choices of what type of design to pick for each of those elements of the assembly. And as you make those choices, it obviously has impacts on the way that the product performs in service operation and its physical cost. You know, what does it require to put it together? And what we try and do in the game is, through a series of rounds, allow you to make different choices, so you can start to get a feel for how those decisions impact the financial performance over a period of time. So can you move me to the next one, Ian? So it allows you to play a number of rounds in the game. You come into the game with 3 years of experience already under your belt. The scenario is you're brought in as the new design chief of the organization. Your job is to turn around what appears to be a poor decision to move into services because we're progressively losing money. And the requirement is for you to turn that around by making better decisions and coming up with a design which better suits the service offering that the customers are demanding and the boardroom believe is going to put them into a better competitive position going forwards. So at the end of each of the rounds, you get the feedback on how well you've done, and you can see how well you're progressing versus the target line as you go through. Next one for me, Ian, please. And as you work your way through each of the rounds, the game is designed to be educational. So you need to spend some time talking to the members of the board. They'll provide you with some valuable insights about how they see competition with other organisations being benefited by a move to services, what kind of services they think they want to be in a position to offer. And there's also the opportunity to meet the customers. And again, you'll get a different expression of what kind of information or what kind of service the customers are looking for and what drives their concerns and their desire to see something different to just a supplier of washing machines for them. So the game is used to try and give you that kind of more interactive way to examine some of the material that's in the mini guide. And if you use the workshop type approach, we use the game as part of the facilitated activity to really try and get you to think about each of the principles as we work our way through them during the material, and get you to test out how they work in practice. So hopefully the game, works as a good tool to make what has the potential to be a slightly dry subject somewhat more interesting when you get the chance to actually go and play and see how well you can do in practice. Next one, Ian. So as we work through the workshop, primarily we spend most of the time going through each of the 5 principles in some degree of detail, really trying to get to the crux of what is each one about, what are the things you have to do, how do you do them, and we've made a really determined attempt to simplify each one down. So essentially we boiled down a couple of decades of learned experience through trying to do this in practice in real organizations and try and turn it into the shortest and most concise route map we can to get the thought processes that you apply in the design process better attuned to the service requirement.
That's great.
And as you can see, we try to be as visual as we can in the training materials or the workshop materials.
That's great, Andy. Thank you very much indeed. As you said, you've tried to boil down into 5 steps, 17 years worth of experience, and we've tried to boil down into 4 slides, a summary of what the approach is. If we could just explore some of the things on the screen here, Andy, if that's okay. So if you just focus at the moment on the first principle, in your experience, in design, in the field, and using this approach, where do things tend to go wrong? If that first principle is missed, if we don't do that consideration, what sort of failures do we get in terms of the process if we don't carefully consider the first principle?
It tends to be a reversion to normal practice. And maybe the best way to describe it is with an anecdote. So back in my Rolls-Royce days, when I was still employed by them, Rolls-Royce sells engines and then it sells a long-term maintenance contract generally. And those maintenance contracts are sold on a dollar per flying hour basis. So essentially, for every hour the engine operates, the airline pay a certain number of dollars at the end of the month to Rolls-Royce. And that covers all of the maintenance activity that takes place on the engine. And Rolls-Royce then in turn flows some of that down to some of our key suppliers. And I remember being in a design session on one occasion where one of these suppliers was in, and we were running through a design for service activity with them. And it became blindingly obvious partway through the session that the designers we were talking to had no idea that their contract with us was that for a certain number of cents per flying hour, they were going to pick up all of the cost of maintaining their part. So we were talking about, well, you've designed this part to last, let's say, for example, 4 years in operation, and then you're going to swap it out and put in a new one. And we're going, well, why don't you make it last 8 years? And they're going, well, we don't need it to last 8 years. And you go, well, you do know you're paying for every new one that you put in, don't you? And if it lasts 8 years, you're going to pay half as much. And they kind of just looked at us blankly, like, well, I'm surely we would have been told that. So this first one is really about breaking that communication gap that tends to happen between what the sales team are off selling and what the design team believe they're designing to support that activity. And you can very easily find yourself in a position where the designers are designing something to be really cheap and cheerful and get out of the factory quickly and efficiently and at low cost. And the salesman has sold guaranteed performance for the next 20 years, which is utterly incompatible with the design spec the designers are working to. So this is really about getting everybody on the same page. The entire organization understands where it's going and why, and you get that alignment then of product and future sales.
Okay, and the word customer is in there, Andy. Have you had an experience of actually having a customer in the room for doing this sort of a process?
Absolutely, yeah. So again, the first product we applied this methodology to in Rolls-Royce, we had the benefit of having one of our airline customers, the launch customer, actually provided us with a senior engineer, and he came and lived on site with us for 2 years during the design process, and he sat in the reviews with us, and it was really really helpful. So most of our designers had never met a customer. The problem with designers are they're way too honest and open, and that, you know, the view had tended to be that you stick them in front of a customer at your peril because they're likely to say the wrong thing and cause all sorts of reactions. And we took entirely the opposite approach on this occasion. And not only did we put them in front of the customer, we then showed the customer everything that had ever gone wrong with that part of the engine design before, and then got the designer to promise that they were not going to make the same mistake again to the person who was going to be flying on the first aircraft to be delivered.
Very open.
Got, yes, surprisingly good reaction from both customer and our internal team.
Yeah, excellent. Very good. That's great, Andy. So just moving on to the second principle. I mean, other than the fact we're showing a 4-leg stool, we're using the term balance here, and we could argue that a 3-leg stool is better for this. Why do you emphasize that there's a balance requirement here in the requirements? And could you also just explain why you pull out both physical products and the technical instructions as 2 different ways of resolving these things? Why balance, and why both product and technical instructions do you pull out here?
Well, I guess the easiest way to think about it is, if in order for a product to successfully support a service, so if you think about the service being the seat of the stool, ideally you want it to be nice and stable and level and perform its function properly. And the things you've kind of got to get right are the product has to do what it's supposed to. So when it leaves the factory and it's used for the first time, it will have a certain set of functional requirements. And every organization is used to designing for that in some shape or form. You've then also got to think about how it's used. So put yourself in the shoes of the customer and pretend, for a lot of these advanced services, what you're really talking about is selling outcome. So the customer doesn't want the thing you're selling physically, they want whatever it produces for them. So put yourself in their shoes and ask the question, how are they going to operate? What do they really need and want? And understand some of the dynamics of that. And that may mean that, again, if you take the example of a gas turbine engine that hangs under the wing of an aircraft, that basically means the customer really doesn't want to take it off more often than once every 4 years. So it needs to sit there and work for 4 years. And that means 13 hours a day, 365 days a year. And your only window of opportunity to go and do anything to it is about 3 hours overnight, if you're lucky, and the occasional slightly longer slot. So the usage requirement means it not only has to work, but it has to work for 4 years. Oh, and by the way, when an aircraft takes off from Singapore, it might not get back to Singapore for 7 days by the time it's hopped all around the world doing a series of legs, and all of the maintenance happens in Singapore. Otherwise, it costs the airline an arm and a leg to get it done by a third party. So it has to be guaranteed that when it leaves Singapore, it has 7 days of flying without any issues whatsoever, guaranteed. So making sure you've got that right is critical. You've then got to think about for products which have a lifespan, meaning they are going to have some maintenance activity, how are you going to fit that in? What's the practical method by which you're going to deliver that? Are you going to maintain it where it is? So do you maintain that engine whilst it's attached to the wing? Do you take it off the wing and maintain it at the airport? Do you ship it halfway across the world to a maintenance facility? And potentially at a very high cost of transportation. So thinking about the practical issues of who's going to maintain it, where is it going to be maintained, when, with what type of equipment. So essentially it's your service delivery system. So what's your mechanics for actually delivering the service itself? And then the final set of requirements are really all about the financial returns. And making sure that you are providing the things for which you're going to get paid ultimately, and for which the customer assigns a value and is prepared to convert that value into something they pay you. So getting those 4 right is key. And the other part of your question was, the physical and technical instructions. If the unit of currency here is output from using the equipment or the product that you provide, you have to consider everything that contributes to that level of usage. And that is not just having a product which works, it's having a product which works and having knocked down anything that prevents you using it. So that might be a lack of understanding of how to use it, lack of confidence that it's going to work, all of the sundries that go into fueling things or oiling them, any of that kind of thing, all has to be addressed. So it's not just enough to have a brilliant physical product, you have to have all of the technical instructions that go around it that say how is this going to be operated and how's it going to be maintained throughout its entire lifespan.
Okay, so you're really pulling that technical instruction piece really forward in the design process rather than leaving it as an afterthought at the end once it's been shipped and got off to the customer then.
Yeah, absolutely. So, I mean, I've no idea if this is true or not, but I remember hearing an anecdotal story that there was a certain design of Aston Martin where the air filter was mounted underneath the engine. So the only way to change the air filter was to lift the entire engine assembly out. It's probably great from the point of view of the designer, having found somewhere to put it. Absolutely terrible from the point of view of the maintenance team, who had to then do something about it.
Yeah.
And I'm pretty sure the owner was not that happy either.
Yeah, you can see they're not meeting their customer requirements, can't you? That's great, Andy. So just looking through the next thing, I guess I understand we've gone through the principles there, that there must be a desire within a design environment to then want to get to, I think, step 4. What happens if people skip step 3? This identifying, you mentioned finance, the end part of that question, that answer. What happens if we don't do step 3?
Look, the key to step 3 is understanding where you can have the most influence. And what tends to happen, as you rightly say, is you jump to the things that you think you can change, or you jump to the things which represent the biggest numbers. So very often, particularly if you're talking about an existing product that's in operation and you're now trying to change it to suit a service, you may go and look at all of the costs, find the biggest one and go, right, we're going to have a team and they're going to go and change that particular cost. And even more worryingly, quite often, the teams are pointed at where the cost is the biggest difference to what the finance team thought the cost was going to be. So you end up with these sort of, go and tackle that particular bit of the equation, and people forget to ask, but where do we have the most opportunity to actually change that number? So it may be that there's a number half the size, but you've got 3 times the level of leverage to actually change it. So that, the thing I kind of always got people to think about is you need to map out where the costs are and their relative magnitudes, but I also want to see a map of their variability. Because if you find me a medium-sized cost that is highly variable between different products, I'll tell you it's one that's open to being influenced. So you find one where the cost is relatively high, and there's probably a good chance you can drive it to being relatively low. So step 3 is that, make sure you put your time and attention in a place where it's most likely to yield an effect, not where it's the easiest to go and point somebody to.
Okay, that's great, Andy. Thank you very much. And if we just go to principles 4 and 5, it looks like a continuation of the logic there about focusing on the key areas and critical things. So could you just talk us through 4 or 5 that leads us through to the end of the process that you've got there? It looks like some fault tree type graphic there. So what happens next as you finish this process off and lead to a better product design?
Well, the key to step 4, or principle 4, is we talk a lot about events and the fact that what tends to happen in service is it's a bit like somebody racking up a set of dominoes and then knocking them over. You get one event, and that event cascades, then causes other things to happen. And what you're in danger of doing if you kind of just get stuck at step 3 is, and maybe best to describe this with an example. A lot of times, the data you will have available to you that says what your costs are will come from transactional systems. And generally speaking, you will have far more data on the transactions which are smaller and take place more often. So if you tasked a team with taking cost out of maintaining a particular product, they're likely to go and discover that you spend a lot of money on taking it apart, you spend a lot of money on replacing bits, and you may spend a lot of money on repairing items. And the temptation is to look at what that final spend is. So I've seen occasions where there's been a high cost of replacing components at repair at maintenance activities, and the immediate thought is, well, we need to be able to buy those parts cheaper. So let's go and get the purchasing team to go and negotiate a lower price for that particular component. And what we try and do in step 4 is go, but hang on, there are 2 parts to this equation. There's how often does something happen, and then what does it cost when it happens? So you're trying to address the cost when it happens. You're assuming we have to replace the part, and you're trying to drive the cost down. But ask yourself the question, why are we replacing it? What is it that has caused that to happen? As you work your way back up the causal tree, what you tend to find is that a product is operated for a period of time. At some point in time, a decision will be made that it now needs to be maintained. And that may be a good decision or a bad decision. And when that decision is made, there's another following decision that says, will we or won't we look at this particular part of the product? So is this component something we want to maintain at this point in time? And then there's probably a set of technical instructions that say, when you look at that particular component, what is acceptable and what is unacceptable. So you've been through 3 sets of decision-making processes to reach a decision that said, we need to replace this part. And only then do you trigger the cost of buying a new one. So actually, you've got 4 different places you could go and tackle that problem. You could continue to use it for longer before you put it into a maintenance activity. You could choose not to look at that particular component, or you could put in different criteria that say what is or isn't acceptable. And you may well get to the position where you can get 100% cost reduction on that replacement activity by choosing not to replace it. But if you were to chase a cost reduction from the manufacturer, you'd be lucky to get 10, 15, 20% if you were really aggressive.
And I guess going back to your earlier example, Andy, whereas I guess this looks like, I guess, a set of extra constraints or requirements on the designer to think about these extra things, it actually frees up some opportunities, because if you're responsible for looking after the life of the product through its complete life cycle, you've got the opportunity to maybe design things better quality that reduces those maintenance ongoing costs, haven't you? So there's a freedom there as well as a set of constraints, I guess.
Absolutely. And it's almost frightening how blind most design teams are to the reality of this. So there's a really interesting question I used to ask the Rolls-Royce designers who I trained in this subject. So at the start of any workshop, you'd ask them the question, have you heard of Total Care, which was the Rolls-Royce branded service which sold maintenance as a $1 per hour contract. So pretty much 100% of the designers say, yeah, we know what that is, and we can describe that. And they got the basics right. We get paid for every hour of operation, and we pay the costs of maintaining. And then you say, and you've heard that described as power by the hour, yes. So do Rolls-Royce sell engines? Nice simple question. So put your hand in the air if you think the answer is yes, Rolls-Royce still sell engines. And sort of sheepishly, about half of the population would put a hand in the air, clearly not very decisively. And the other half would vote in the opposite direction. You go, so well, this is pretty fundamental, isn't it, really, that you're designing the engines and you don't know if we actually sell them or whether they belong to us and we simply sell hours of use. And shouldn't that have an influence on the way that you think about the design? And Rolls-Royce are absolutely, completely normal in that respect. I would say, the likelihood that a designer has seen a product that has been used and has been returned for maintenance is probably less than 10% in most organizations. And the only people who ever see the reality of the product having been used will tend to be the ones who are tasked with fixing any in-service problems that arise. So your simple acid test is, do you know how long your product works for before it's disposed of? Do you know how often it gets maintained and by whom? And do you know the ratio of the cost of making it to the cost of keeping it working over its lifespan? Because you might be quite frightened by the ratio of those two numbers, particularly for a long life product that gets a lot of usage.
Yeah, and especially if you're changing a business model from one where you do sell the asset to one where you're going to an outcome-based contract where you don't sell it and you're responsible for its life cycle.
Yeah, and to be honest, business isn't that clean. So you will not make an overnight switch from one business model to another. You will have some contracts on one set of terms and some contracts on another. And that's an interesting dilemma, because you can't ask the design team to design two things. Well, you might decide you want a different product for different sales environments, but in most cases that's not practicable. So you will end up having a compromised design which you're trying to sell in two different ways, and it might not be ideal for one or other of them.
Yeah. Okay, that's great, Andy. So let's go back to the last principle then. So targeting the improvement will have the best impact. Again, that consistent with that focus, criticality you've introduced in steps 3 and 4. What's the key thing about principle 5 we should remember, Andy?
It's really getting into the crux of the vast majority of product services are about keeping it working. So the inverse of that is, why does it stop working? And it's because things wear out. So principle 5 really talks a lot about the processes by which wear and tear occurs. So things deteriorate, they stop doing having the functionality you require of them, and eventually they'll reach the point where they fail. So you're attempting to avoid reaching that failure point. So we talk about, how do you catch it? How do you prevent it happening on a timed basis? How do you prevent it happening on a kind of more physically monitored basis? And then how do you recover back to the level of functionality you need to launch it back into operation again for another period of time? And in particular, we talk about this concept of avoid, contain, recover, and convert. So avoid is essentially, can you change the dynamics of the wear out process so that the need to maintain is avoided for as long as possible. Contain is all about your ability to catch it and prevent the worst outcomes of things approaching the point of failure. Recover is all about the dynamics of the maintenance activity, which restores health back into the product. And then the convert is convert all of your experience in that process into the ability to do it better the next time around. And we spend a lot of time talking about why avoid is the better strategy if it's available to you. So again, why spend money fixing something if it never needed to wear out in the first place?
Yeah, no, very, very clear, Andy. And again, from these graphics we've got here, a very visual approach as well to try and solve the problems for teams to try and work through these things.
Yeah, well, I mean, the great thing about engineers is they're natural born problem solvers. So providing you can articulate what the problem is in a reasonably coherent way, and ideally with some pictures, since most engineers tend to be more picture oriented than word oriented, then my experience is you get an overwhelmingly positive response to, right, I see what you want now, and you've shown me some relatively simple, clear ways of getting a grip on the problem and not getting lost in too much complexity.
Yeah.
Which is really the key. Ideally, if you follow the 5 principles, you know what you're trying to fix, you can quickly target the areas of best opportunity, and you can narrow down to the 1 or 2 things that need to change in order to get that effect at the minimum cost, minimum lead time, and minimum effort.
Yeah. Okay, that's great, Andy. What I'll do is we'll just we've got some questions that have come in from the audience, Andy. So I'm just going to pull this up in front of me. We won't get through all of them, but I'll just pick out a few, and we'll list the others out and we'll respond to those afterwards. The first thing I'll just pull through here is a question here about timing of using this process, Andy. So the question is, when is it too late to do this process? Can the process be used to redesign for service for installed bases, or has the boat sailed by the time you've got an installed base out there?
You can use it at any time. You're obviously more constrained. So part of my kind of past history is many years as a new product designer. And I'd say it's probably most effective in that arena because you're providing most room for movement for the design team. But equally, I've spent many years looking after in-service products and resolving the issues that take place there. So anytime you go through the design cycle, then you have the ability to do this. And it may be something you tag on to. There's already a need to change a particular component in a product. So maybe you've decided something's expensive and you want to cost reduce it. You can look at its through life cost profile as well as its cost to purchase type profile. So you can certainly do it in service. There are all of the difficulties of it's far more expensive to change something that already exists than to decide and get it right on the first pass. But it's never too late to start.
Yeah, and I guess in heavily regulated industries, changing things adds its own complexities to it as well, I imagine.
Absolutely, yeah.
Yeah. Okay. Thank you very much, Andy. Michael, you've got some lovely questions coming from yourself. I'm just going to pick one or two. The first one that Michael's put out for us here is a question about pricing, Andy. So the question here is, where in the design for services process does pricing come in? As in for particular customers or particular usages? The example that they give in the question here is using an asset maybe in Central Europe may be very different to the way that the same asset might be used in the Middle East or Siberia or Alaska. So how does different pricing maybe affect the design for service process, or is pricing irrelevant for this process?
No, it's not irrelevant. So what you have to do is part of this thinking about the usage. So on principle 2, one of the legs of the stool was how is it going to be used, and what you have to really get your head around is that different organizations will use your product in a different way. Some will be entirely consistent with the design spec that you wrote. Others will find mysterious ways to use it completely outside of the design intent. And that will have a significant effect on the wear and tear profile that you see. And you have to take account of that. So essentially what you need to do is, and it's kind of a bit of a reverse this. At the start of the process, you would expect that part of the requirement setting is some kind of indication of the expected user profiles. So what sectors are you selling into? How might their usage differ? Some kind of view as to what is an acceptable pricing of a service in those environments. And quite often the price that you can charge for a service is not a case of what will it cost to deliver plus a margin. It will be set by competition with other organizations essentially. So you might get down something that says, the number of pounds per operating day that you're allowed to spend maintaining it is 12 in this environment, but 47 over here, because this group of people know that they wear it out a lot faster than the other group. So they expect to pay more. And that may then flow into the process as a set of requirements and constraints that say, whatever you come up with the design, it must live within this cost profile in order for us to be able to sell a service and for that service to be profitable. There is a flow back the other way, which is having designed something, can you then predict the ways in which it will perform and wear out and require maintenance in different environments? So, one of the things that is available in this kind of space is life cycle cost modeling, and the ability to start assembling a view of those kind of wear out characteristics. So it's kind of more in the Principle 5 arena, where if you start to understand those wear out dynamics and statistics, then you can start to construct those sorts of models and get a view of, well, what if we sold it to this group of people over here and they used it in this way? Is that going to double, triple, halve the kind of support cost profile we might see, and therefore how might we think about doing the pricing?
Okay, thank you. And Sanjay's asked a question here, which I think you've just touched on there. The question was, how do you predict failure? So I guess you were just starting to go into that, really talking about pricing, but predicting failure, obviously it's easier when there's long history. What about when it's an unknown area?
Yeah, it's largely statistical. So there are various ways of doing it. Some are considerably better than others. So if I remember going on a course once being taught about this kind of topic from a military perspective, and the military require that their suppliers perform a particular process, and it says you must do statistical analysis of failures, and here is the book, and the book tells you what all of the statistical numbers are, and you kind of look at it and go, well, that book was written goodness knows how many years ago, that can't still be right. And I sat in a room with that group of people, and they were moaning bitterly, the other people on the course, because they all came from the military side of things, saying nobody ever takes any notice of our predictions of how often things will break. And I go, well, do you believe your predictions? Well, no, not really. So why are you surprised nobody else takes any notice then? Yeah, but we have to do it the way the book says. But clearly the book's wrong then, if you know it's not a good prediction and nobody takes any notice. So you kind of have those sorts of fixed, the answer is it's always 14 failures per 1,000 operating hours, or you can look at a more age-based approach. So particularly kind of in the world I came from, we used a lot of Weibull modeling, so more age-based probabilities of things failing. So recognizing that some failure modes happen early in life, and then if you survive a certain length of time, you're almost never going to suffer from it. Others tend to creep in at higher life, and there are some random ones. So finding an appropriate methodology for which you can derive some statistical numbers. So some might be pure prediction, some might be based on historical evidence, is quite useful. The other thing you can do, and I've found this very useful in many occasions, is make it up. Build a simple model and guess some numbers. And particularly if you build a model that says, well, it could be this bad, it could be that good. Run the model and it will tell you which of your assumptions are actually important and which ones are utterly irrelevant. And then you can focus your attention on narrowing down and becoming better on the things which truly have an influence. And it's really quite educational. So, we certainly built models in the past where we've gone, oh, that answer can't be right. We must have got the modeling completely wrong. There's a mistake somewhere. And then when you run through it and go, actually, there's not a mistake. That really is what the outcome for this set of inputs. And it really focuses your attention on thinking, oh, actually, I didn't realize that was important, but there's a
Again, it's a focus tool. It's a focus tool with the sound of it. Again, we've got a range of about 13, 14 of the questions. I'm just going to pull out one more, I think, before we finish. So Eddie asked the question here, and clearly looking for a maybe a less accurate answer in terms of principle, but in general, what's your recommendation about how to win the hearts and minds of designers to this more open-minded approach? What's the way to get the designers, the technical people, to see this and take it to heart?
Dead easy. Tell them the problem. You'll find most resistance is generally because you've not articulated it as a problem for them to get their teeth into. So I guess the two things a designer wants is be clear about what you're asking me to do, and actually don't tell them what to do, tell them what you're trying to achieve. So describe it as a problem statement, and try and simplify the route to an answer. So essentially what we do here is we go right to the beginning and say, well, the best way of doing this would be to get the salesman in the room who is trying to sell a service and get them to describe what they're trying to sell and why they're trying to sell it that way, so that the designer can understand, the motivation behind some of the weird and wonderful requests that might come through into the design space, and then help, if you provide them with some of the tools around the other principles, it really simplifies the process of going, well, what do I need to think about next? You could easily become overwhelmed with all of the things you could go and change, and it's about having a nice sequential process that helps narrow down to, actually, no, that's the only thing you need to improve. If you did that, that would be a big step the right way.
Okay, that's right, Andy. Thank you very much indeed. We've got about another dozen that we haven't had a chance to get through, Andy. So maybe we'll get hold of those and we'll print them out and share them with you. Perhaps you could maybe look through and give us some extra response if that's okay. Okay, lovely. Thank you very much indeed. So just to conclude the session today, just a reminder about our Servitization Live event in October. Free to register. Lots more information about Servitization. Everything's a service. It's going to be run across the 3 days in October. Really recommend you come and join us and find out how manufacturers are moving up that services staircase, looking to advance their businesses through advanced services. And again, just a reminder that if you would like to further engage with us, to access the IP, the game, the mini guide, etc., then Andy is available to work with us and with yourselves about this. You can get the mini guide. The mini guide is going to be available on our website now. We've got a link which will go out to you to access it at a reduced price for the end of the month, and that also gives you access to the mini guide and the game as well. And we can also come and help you with your technical challenges too. So, Andy, thank you very much indeed for your time today and taking us through 17 years of experience in 5 principles in about 45 minutes or so. Thank you very much for your time, and thank you very much everybody for attending. Please come along and join and join us again at a future webinars, and see you in Servitization Live. And Michael, yeah, we'll get back to you with regards to the presentation. Thank you very much indeed. Thank you very much, everybody. Have a very good afternoon. Bye-bye now.
Thank you, everyone.